Hello, in this video I will be showing you how to find the equivalent resistance of a somewhat complicated looking circuit. So the first thing we'll look at is how the circuit is displayed and what methods can we take a look at that will simplify the circuit. Typically what we want to break it down to is simple parallel and series combinations that will give us the final result. But in this case, as we can see, there's a bunch of triangles in the circuit, which might look intimidating. But if we take a look at the equation I have written down here, it shows us how to convert from a delta looking combination of resistors to a Y. The reason why we want to convert from delta to Y is it will allow us to have the resistors connected to each other in both circuit and parallel combinations, which will give us an easier way of solving the circuit. So if we start from the top, we'll find that we have three 3-ohm resistors in delta formation. What we will do is we'll use our formula here and we will convert them to a Y formation. We can do that by solving for A, which we can show as 3 times 3 divided by 3 plus 3 plus 3, which gives us 9 over 9, which is 1 ohm. Now, by realizing that the circuit is completely symmetrical, meaning that every resistor is the same, we can conclude that RB and RC will follow suit to be equal 1 ohm, just because the numbers in the equation will be the same. So this would be RB, which also is RC. Now after we get that, we can redraw the circuit. If we redraw the circuit starting from A, we can go down, draw our first RA resistor, and then we can draw our RB and RC. Now if we look where they connect at the nodes, there's a node here that will share two more resistors, the 2 ohm resistor and the other 2 ohm resistor, which will combine at the end here, and they also will have the 1 ohm resistor and the other 1 ohm resistor as well as here, and we go back to B. Now if we look at this combination, what can we figure out from here? We know that these resistors are in series with each other, so we can combine them as follows. Because this is 1 ohm and this is 1 ohm, we get 2 ohm. This is the same thing. It's a symmetrical circuit. And after we combine these, we can redraw the circuit one more time. And we will get the 2 ohm resistors here. But now we have just one resistor on each side in parallel with the 2 ohms. So this is a 2 ohm, 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 1, 1, and 1. Now, because these 2 ohm resistors share node on each side, that means they're in parallel. So we can combine these as well as these in parallel, and we will redraw the circuit one more time to remember how to combine resistors in parallel. We can go as R EQ 1, let's call this 1, and it would be just 1 over R1 plus 1 over R2, and we take the inverse of that. So this R1 would be the 2 and this R2 would be the 2, and we would get a result if we just quickly plug it into the calculator. 1 over 2 plus 1 over 2, and we take the inverse. Well, we would just get 1 ohm. And again, we know the other side is the exact same, we'd get 1 ohm as well. So now if we redraw the circuit one more time, we would get this combination, all in series with each other, and they end at B. So we have 1 ohm here, we have 1 ohm here, 1 ohm, 1 ohm, 1 ohm. We can combine these and these in series. We'd get 2 ohms, we get 2 ohms. Now we know if we add these up in parallel, because we'll combine them, we'd get 1 ohm. and then we would add this total combination of 1 ohm to this one, and we would get our equivalent looking into A and B here as 1 plus 1, which would give us 2 ohms as our final answer. Thank you.